Hello everyone, welcome back to our channel. If you are working in the field of instrumentation, process engineering or industrial automation, today's video is going to be super valuable for you. Today we are going to learn everything about the Venturimeter, what it is, how it works and what its structures look like and the science behind it. So without wasting the time, let's get started. The topic of today's video is what is Venturimeter and how it works. A Venturimeter is one of the most important widely used flow measurement device in the process industry. Where it is an oil, gas plant or water treatment facility or a chemical plant, you will find Venturimeters being used everywhere. By the end of this video, you will have a very clear understanding about this instrument. So make sure watch till the very end. For gas measurement, a Venturimeter operates by measuring the pressure difference between these two different points showing here. So the first is what exactly Venturimeter? A Venturimeter is a DP, yani differential pressure type flow meter. It is used to measure the flow rate of a fluid with whether it is a liquid, gas or steam flowing through a pipe. The basic operating principle is very simple. A Venturimeter works by measuring the pressure difference between the two specific points that are mentioned in this picture that you are able to see. Okay. So now the next question is, how is the pressure difference actually created? The answer is by introducing constrictions. This constriction, that means narrowing in the pipe. When the fluid is flowing through the pipe, it suddenly encounters a narrow section. What happens? The fluid has to speed up because the same amount of fluid has to pass through the smaller area in the same amount of time. And when the velocity increases, the pressure drops. This is the core principle. So the Venturimeter creates this narrowing intentionally and measures the pressure before constriction and the constriction. And the difference between these two pressure tells us the flow rate. So this is the fundamental concept and it is based on the two very important scientific principle which will be seen in the next slide. So structure, now we have to look the structure of the Venturimeter. A Venturimeter has a three main section. First is the converging part. Let back to the slide. So the first one is the converging part. This is the inlet section. As the name suggested, the pipe gradually narrows down and from the full pipe diameter to a smaller pipe diameter. The fluid enters here and start to accelerate as the area reduces. Now the second part is the throat. This is the narrowest section of the Venturimeter. The velocity of the fluid is maximum over here and the pressure at its lowest point. So this is where the lower pressure trapping is supposed to be happen and it is there. And the next and the last part is the diverging part. After the throat, the pipe gradually expands back to the original diameter, and this is happens because this is supposed to be happen because the velocity decreases and the pressure recovers. This gradually expansion is very important. It reduces the energy loss, makes the Venturimeter more efficient and compared to other flow meter like Orifice Plate. So the main three parts are converging, throat, diverging together form a complete Venturimeter. Now it works on basic principle. One first principle is basically work on the two concepts. One is the continuity equation and the another is the Bernoulli's theorem. So the Venturimeter actually follows both the theorems. So first we will talk about the Bernoulli's theorem. States that in the flowing fluid that the total energy remains constant, but it can change form between pressure and energy, velocity and potential. In simple words, I can say when velocity increases, pressure decreases. When velocity decreases, pressure increases. This is exactly what happened in the Venturimeter. As fluid speeds up in the converging section and reaches the throat, velocity goes up and pressure comes down. This pressure drop is what we measured. Second is the continuity equation. The continuity equation is basically based on the principle of conservation of mass. Meaning is that mass cannot be created nor be destroyed. So the A1 into V1 is equal to A2 into V2 means that whatever the mass flow rate is inletting, the same amount is going outside. So putting it together, the fluid enters the area and decreases the velocity and increases. Velocity increases. And when the pressure drops, this pressure difference is measured using a mathematical formula, calculate the flow rate Q. So now we move to the another slide. Now let's understand the pressure tapping locations in the Venturimeters. At the beginning of the conversion section, at this point, at the beginning of this conversion section, at this point, the pipe. At this point, the full diameter at the full diameter, so the velocity is lower and the pressure is higher. Whatever the coming from the input side, this tapping captures the upstream pressure. So, and the next one is the low pressure tapping. This is located at the narrowest part. Here the velocity is maximum and the pressure is minimum. So this tapping captures the downstream pressure. So the differential pressure between the P1 and the P2 is called the delta P, and both delta P is sent to the differential pressure transmitter, and that transmitter convert this pressure difference into a 420 milliampere signal, which is then used by the control system in the PLC and the DCs to calculate and display the flow rate. So in the converging section, you can see area decreases, velocity increases, and pressure decreases. And this relationship gives the measurement what we required. So the friends, that was the complete explanation of the Venturimeter from its basic concept to its structure to its working principle and the pressure tapping locations. So let me give a quick summary. A Venturimeter measures flow using DP. It has a three part. One is the converging section, throat and diverging section. The throat diameter is half the pipe of the diameter. It works on the Bernoulli theorem and the continuity equation. It is more energy efficient than the orifice plate due to the lower permanent pressure loss. I hope this video was helpful and easy to understand. If you like this video, please give it a thumbs up. It really motivates us to create a more quality video and content like this for you. And if you haven't subscribed to our channel, please subscribe right now and hit the bell icon so that you don't miss any future videos. Also share this video with your colleagues and friends who are in the instrumentation or engineering field. If you have any question or doubt, drop them in the comments below. I will be happy to answer. Thank you so much for the watching. See you in the next video. Take care.